Okay, we're going to talk now about 4.2 multiplying matrices. The product of two matrices A and B is defined provided the number of columns in A equal the number of rows in B. Okay, so here's A, and we usually put the dimensions of a matrix in the underneath or lower left-hand corner. I've got them made a little bit bigger here, but it would have M rows and A would have N columns. Okay, and if this product A times B is defined, then the number of rows, the number of columns rather, in this one, it's rows by columns, okay, has to equal the number of rows in the second one. This is rows by columns, okay. So these numbers have to be the same, and the resulting product, or the matrix AB, is going to have the rows of the first and the columns of the last. So it's going to be M times P. That's how big it would be. That would be the size of it. Okay? All right, let's take this out. And let's move on. Okay, the dimensions of the product AB will be the number of rows in the A by the number of columns in B. I've already said that. Example 1. If A is a 2 by 3 and B is a 3 by 4, does AB exist? Well, what we're going to have to check is to see if this number is the same as this number, and it is. So if so, what would the dimensions be? So AB would have dimensions 2 by 4. It would have 2 rows and 4 columns. If C is a 3 by 2 and D is a 3 by 4, does CD exist? Well, we check the columns of the first and the rows of the second. They have to be equal, and they don't, so CD does not exist. Try a couple of these. Okay. Assuming you did these, then since 4 does equal 4 here, the columns of the first and the rows of the second, it does exist, and the dimensions of this would be the first rows of the first and the columns of the second. It would be a 2 by 3. In this one, since 4 and 1 do not equal each other, does not exist. Okay, we'll just abbreviate that. Does not exist. All right, moving on. Take a look at example number 2. Find A times B if A is this matrix and B is this matrix. Okay? Well, let's figure out if it's even defined first. So we have 3 horizontal groups and 2 vertical groups. So this is a 3 by 2. B is a 2 by 2. Since 2 equals 2, these are the same, we take them out, and what we're left with is a 3 by 2. So we've got this 3 by 2 answer down here. And the first thing we're going to do to proceed with this problem is to take the first matrix in this product. A is on the left, so we're going to call A the first one. So we take A and we divide A up into rows. We do this every time with matrix multiplication. The one on the left is divided into rows, and the one on the right is divided into columns. So we have row 1 that has elements -2 and 3. Row 2 has elements 1 and -4. Row 3 has elements 6, 0. And the second one, the column 1, has the first element is 1 and -1, and the second element is -2. In column 2, it's 3 and 4. Okay, now this will always be the case with matrix multiplication. The key to determining the numbers that go in the this answer here are the position each one has in the answer. So we're starting with this upper left-hand corner. This is row 1, column 1 of our answer. So we've already taken our problems and broken one of them into rows and the other into columns. So we're going to go take row 1 and column 1, and we're going to multiply them. Okay? Now let's reiterate something here. Rows are ordered from left to right, first, second, and third. So -2 would be the first element, and 3 would be the second element. Columns are ordered top to bottom, so -1 would be the first element, and -2 would be the second element. Okay? To multiply row 1 by column 1, you pair up the corresponding entries, and by that we're talking about first element times first element, and then second element times second element, and then multiply and add these. So I'm going to take the first element in A, negative 2, and I'm going to multiply it by the first element in column 1, negative 1, and I'm going to add to that, and it's add every time. Okay, I'm going to add to that the second element in row 1 times the second element in column 1, and that's going to be 3 times negative 2. Well, negative 2 times negative 1 is positive 2. 3 times negative 2 is negative 6. 2 plus 6 is negative 4, and this is what goes in our answer here. Now, where matrix addition and subtraction is very intuitive, it's just like you would set them up. We've talked about that in 4.1. Matrix multiplication is not so obvious, and it takes learning a process, and so this is the process. All right, so we go to our answer, and we want to determine what goes into this space right here. Well, in the answer, it's the position in the answer, it's row 1, column 2. So we're going to take the numbers in row 1 and times them by the numbers in column 2. Okay, so let's erase what we did over here. And now I'm going to be taking this row times this column. Okay, I'm going to do that down here. So I'm going to have the first in row 1 is negative 2 times the first in column 2 is 3. And add to that, and it's always add, the second in row 1, which is 3, times the second in row 2, which is 4. And we get negative 6 plus 12 equals 6. 6 is what goes here. Okay? All right, let's go to the next point in our problem. Row 2, column 1. So I'm going to take this row and I'm going to multiply it by this column. So I'll pair those numbers up. We're going to have to find some empty space here. We'll do it right here. So this will be row 2 times column 1 here. And it's going to be the first element in row 2, 1, times the first element in column 1, negative 1. Add to that, it's add every time. The second element in row 2, negative 4, times the second element in column 1, negative 2. Now we just complete that by following the order of operations. We have negative 1 plus 8. This is going to give us, negative times negative is positive. It's going to give us 7. So for row 2, column 1, it's 7. Let's continue. Now we're going to do row 2, column 2. So we're going to take row 2 and times it by column 2. Okay? Let's do that. We're just going to put these all over the place. Let's do row 2, column 2 up here. So take the first number in row 2, 1, and times it by the first number in column 2, 3. Add to that the second number in row 2 times the second number in column 2, negative 4 times 4, and that's going to be equal to 3 plus negative 16, or negative 13 goes here. Okay. All right, next piece, next part of the answer. We're going to do this one. So that's row 3. Let's put that right here. Row 3, column 1. So we take this row times it by this column. We'll do it underneath here. First in the row 6 times first in the column negative 1 plus second in the row 0 times second in the column negative 2. We get negative 6 plus 0 equals negative 6 goes here. And now we'll do row 3, column 2. Apologize for putting this all over the place here. And we're going to mark this now as column 2. I've already got column 1 marked, so we'll do these two now. So first in the row 3 is 6 times first in column 2 is 3 plus second in row 3 is 0, second in column 2 is 4, and that's going to be 18 plus 0, or 18. And that's matrix multiplication. Okay, let's move on. And I'll get you to try this one. Okay, that should have been paused enough. So first thing we're going to do is we're going to take a look and see if this is even possible. Now you will get some problems, class, where the answer will be not possible because of the dimensions. Well, let's take a look at the dimensions. How many horizontal groups do we have? 3. How many vertical groups? 2. This is a 3 by 2 matrix. And this is a 2 by 2 matrix. Is the multiplication possible? Yes, it is. What will we have left when we multiply this? A 3 by 2. Okay, so if we're going to multiply these two, then we will take our first matrix and divide it up into rows. And take the second matrix and divide it up into columns. Okay, so row 1, row 2, row 3, column 1, column 2. And we've determined that we're going to have a 3 by 2 answer, so I'm going to make an answer blank here that looks 3 by 2. Partition it off so that you can see the rows and columns. It's very helpful. Now, I don't really care to write the positions in here every time. If you want to refer back to the first problem, you can, but this is row 1, column 1. So let's do R1C1 right here. So first in the row, -1, times first in the column, 4, plus second in the row, 5, times second in the column, 6. So here we have -4 plus 30. We have 26. 26 goes here. Okay, let's do row 1, column 2. First in the row, -1, times first in the column, -3, plus second in the row, 5, times second in the column, 8. We have 3 plus 40. We got 43. That was row 1, column 2. Okay, this is row 2, column 1. First in row 2 is 5, times first in column 1 is 4, plus second in row 2 is 2, second in column 1 is 6. We have 20, plus 12, we have 32 goes here. And let's do row 2, column 2 here. So row 2 times column 2. First in the row, 5, times first in the column, -3, plus second in the row, 2, times second in the column, 8. We have -15 plus 16, we have 1. Let's find out what goes here. That's in row 3, column 1. Row 3, column 1. Take row 3 and times it by column 1. First in the column, 0, times first in the row, 0 times first in the column, 4, plus second in the row, -4, times second in the column, 6. We have 0 plus -24. That's -24, and that goes here. And now finally, row 3, column 3. So it's going to be this row times this column. First in the row rather, 0 times first in the column, -3, plus second in the row, -4, times second in the column, 8. We have 0 plus -32. That's equal to -32. All right. Moving on. Okay. Example 3. If A is this 2 by 2 matrix and B is this 2 by 2, then find AB. Okay, well, this is a 2 by 2 and this is a 2 by 2. Is it possible? Are these the same? Yes. If it is, I cross them out. What I'm left with is a 2 by 2. So they want us to find that. It's again a multiplication problem. 4, 0, just copying A over here. And I'm going to put it in this order. A's got to go on the left and B has to be on the right. It has to follow this order. And this is -4, -3, 1, and then 2. Okay? And we said it's possible and that the answer is going to be a 2 by 2. Let's make a 2 by 2 answer blank. One on the left broken up into rows, one on the right broken up into columns. Row 1 times column 1 right here. So let's do R1C1. So it's going to be 4 times -4 plus 1 times 1. We have -16 plus 1, -15. Okay. Row 1, column 2. 4 times -3 plus 1 times 2. -12 plus 2, -10. Negative 10 goes here. I'm running out of room down here. Let's do row 2, column 1 up here. All right, so first in the row 0 times first in the column negative 4 plus second in the row negative 2 times second in the column 1. We have 0 plus negative 2 or negative 2. And then we'll do row 2, column 2, which is going to be this row times this column. So first in the row 0 times first in the column negative 3 plus second in the row negative 2 times second in the column 2. 0 plus negative 4 equals negative 4. All right. All right, over here they want me to find B times A. Now again, we have to put them in the order that they come in our problem. So B has to be on the left. B is the one that's broken up into rows, and now A is broken up into columns. And let's see how these two compare when we get through. So this is going to be B. It's negative 4, negative 3, 1, 2. And it's times the matrix A, which is 4, 0, 1, negative 2. Okay, the one on the left broken up into rows, the one on the right broken up into columns. It's going to have a 2 by 2 answer. So we make an answer blank that looks like a 2 by 2. And we proceed. First in the row times first in the column, negative 16 plus 0 is negative 16. Row 1 times column 2, negative 4 and positive 6 is 2. Row 2 times column 1, 4 times 4 plus 0 is 4. And row 2 times column 2, 1 times 1 is 1, and negative 4 is negative 3. All right, now, what can you conjecture, which means, to tell what you think is true based on your experience, about the commutative property of multiplication and matrix multiplication? If you remember, commutative property says that A times B equals B times A. You can take the multiplication and turn around, and you get the same answer. And that works with the real numbers. But we're dealing with matrix multiplication. And here we have AB, and here's the answer to AB, and here's the answer to BA. And clearly these are not the same matrix. So what can we conclude about commutative property? Matrix multiplication does not hold. It is not a property of matrix multiplication. All right. Example 4. Okay, let's take these three, A, B, and C. They're all 2 by 2s. And so any addition or multiplication is going to work because you're adding, you have to have exactly the same dimensions, and you do. Or if you're multiplying, then the columns of the first have to match the rows of the second, and it would with any pairing here. So we can do anything that they're asking us to do down here, multiply or add these matrix. Okay, so what we're going to do is we're going to set this problem up, and I'll first start by copying B down, and then parentheses, and then put A in here, which is 2, 1, negative 2, 4. And then plus B, no, that's C, 0, 2, 3, negative 1. Okay, so just like we would with real numbers, the order of operation holds true here. So we want to work inside parentheses, and inside the parentheses I see an addition problem. So we would add these 2 by 2 plus the 2 by 2, which will give us a 2 by 2. And what we do with addition, if you remember back to section 4.1, is we just add corresponding positions. So what's in row 1, column 1 over here, we add to row 1, column 1 over here, or 2 plus 0 is 2. Negative 2 plus 3 is positive 1. 1 plus 2 is 3. 4 plus negative 1 is 3. Okay, and then I bring down the rest of this. Okay, so now it's multiplication. That multiplication sign's here. 0, negative 3, 1, negative 2. Multiply these two. It's certainly possible because they're both of them are 2 by 2s. The one on the left is always broken up into rows. The one on the right is always broken up into columns. And when we multiply 2 by 2 by a 2 by 2, we get a 2 by 2. Again, we're looking at the dimensions 2 by 2 of this one, and this one's 2 by 2. These have got to be the same. They are. Cross them out. What's left? 2 by 2. We've been over that on the last problem. Let me go ahead and erase that. Okay, now we're ready to multiply. So row 1 times column 1, 0 times 2 is 0, plus 1 times 3 is 3, 0 plus 3 is 3. Here, this is row 1, column 2 of my answer. So I take row 1, I'll label them here. I didn't do that on the last problem. I think you'll get to where you don't have to label these, but we'll go ahead and put the labels in. This is row 1, column 2 of our answer. So we take the numbers in row 1 and times by the numbers in column 2. First times first, 0 times 1 is 0, plus second times second, 1 times 3 is 3, and 0 plus 3 is 3. Okay? And now we take a look at our answer. This position in our answer is position row 2, column 1. So in our problem, we take row 2 and times it by the numbers in column 1. First times first is negative 6, plus, and it's always plus, negative 2 times 3 is negative 6. Negative 6 and negative 6 gives us negative 12. And now, in our answer, we're looking at the position of row 2, column 2. So in our problem, we take the numbers in row 2 and times it by the numbers in column 2. First times first, negative 3 times 1 is negative 3, plus second times second, negative 2 plus, negative 2 times 3 is negative 6. Negative 3 and negative 6, negative 9. And that would be the answer to B times A plus C. Okay? All right, let's do this one. Okay, find AB plus and then add to that AC. So we're going to have to do the multiplication here before we do the addition. So let's set this one up. Get the B matrix here. 0, negative 3, 1, negative 2 times the A matrix, which is 2, 1, negative 2, 4. We'll go ahead and do that, and then we'll come back and do the second part. So break that up into rows, break this up into columns, and make this a 2 by 2 answer blank. Row 1 times column 1, nothing, and 1 is 1. Row 1 times column 2, nothing, and 4 is 4. Row 2 times column 1, negative 6 and 2 is negative 4. Row 2 times column 2, positive 6, and negative 8 is negative 2. So that's B times A right here. This is BA. Okay? All right, let's find BC. Okay, so we're going to take, we'll put B right here again. So we have 0, negative 3, 1, negative 2. And we're going to multiply that by C, which is 0, 2, 3, negative 1. Make that look like a 1. Okay, with always, the one on the left is broken up into rows, the one on the right is broken up into columns. This is row 1, this is row 2, this is column 1, this is column 2, and we make an answer blank for this. A 2 by 2 times a 2 by 2 yields a 2 by 2. And this is row 1, column 1 of my answer, so I'll take the numbers in row 1 and times them by the numbers in column 1. First times first is 0 times 0, plus second times second, 1 times 2, 0 plus 2 is 2. Row 1, column 2, nothing, and negative 1 is negative 1. Row 2, column 1 of my answer, take row 2 and times it by column 1. Negative 3 times 0 is 0. Negative 2 times 2 is negative 4. 0 and negative 4 is negative 4. Row 2, column 2 is going to be negative 9 and positive 2, so that's negative 7. Okay, this is BC. Okay, now it wants me to add these two answers, so I take the BA answer, which is, here's BA, it's 1, negative 4, 4, negative 2, and I add to that the BC answer, 2, negative 4, negative 1, negative 7, And a 2 by 2 plus a 2 by 2, they remember with addition and subtraction have to have the exact same dimensions to be able to do it, and the answer has the exact same dimensions as the problem. A 2 by 2 plus a 2 by 2 yields a 2 by 2. How do you add? Just add corresponding entries. Row 1 column 1 plus row 1 column 1. 1 plus 2 is 3. Row 1 column 2 plus row 1 column 2, 4 and negative 1 is 3. Row 2 column 1 plus row 2 column 1, negative 4 plus negative 4 is negative 8. And then row 2 column 2 plus row 2 column 2, negative 2 and negative 7 is negative 9. Okay. Let me go back and check this answer right here. This is row 2 times column 2, which is going to be negative 6, and negative 6 is negative 12. This should be negative 8 here. It's negative 6 and negative 2. This should be negative 8 here. And negative 4 should have, so this should be negative 8. And negative 4 should give us what? Negative 12. Now, I knew these should come out to be the same, so I knew I had a mistake in there somewhere, and it was with that with this entry right here. Okay, that was row 2 times column 1 should have been negative 6 plus negative 2, or negative 8, which would have changed that answer. So what we learned from this after I fix that mistake is that if you'll check this answer and you'll check this answer, well, they turn out to be the same. Now, what can you conclude about the distributive property in matrix multiplication? It holds true for matrix multiplication. Okay? All right, I'll get you to try this one. Okay, assuming you already did that, look at the dimensions of this. If they're asking us to multiply, the first thing we're going to do is check the dimensions, because they don't always work. How many horizontal groups do I have? I have one row. Looking from the top, how many vertical groups do I have? Regardless of how many's in that group, there are 3 looking down. So this is a 1 by 3. Okay? And this one is a 3 by 1. Is this possible? Well, are these the same? Yes, they are. What are you left with? A 1 by 1. These are sort of the exceptions to the rule. I don't know if they're exceptions. They just seem a little odd because of the size of the answer and the problem. So we'll put these together and we'll multiply them. So we're going to get a 1 by 1 answer. Now this is row 1 times column 1. We only have one row, we have only one column. How do I multiply R1 times C1? First in the row times first in the column, or 8 times 4. Add to that, second in the row times second in the column, 0 times 6, plus third in the row times third in the column, negative 4 times negative 3. Well, 8 times 4 is 32. 0 times 6 is 0, and negative 3 times negative 4 is 12, and all of that adds up to be 44, and the answer is just 44. So what's odd about this one? Well, the problem's so big and the answer turns out to be a 1 by 1. So sometimes that gives people problems, but if you look at it carefully, a 1 by 3 times a 3 by 1, we check to see that these are equal, we cross them out, whatever's left is the answer. Okay? Now here they want us to find BA. So if we found BA, then it would be a a 3 by 1, which is what b is, times a 1 by 3. And is it possible? Yes. What would you have if you did this? You'd get a 3 by 3. So here the answer is going to be significantly larger than what the problem is. Well, let's take a look at it. So we put b on the left. So it's 4, 6, negative 3. And we put a on the right, 8, 0, negative 4. Now, what do we do with the one on the left? Break it up into rows. What do we do on the one on the right? Break it up into columns. I'm going to go ahead and label these. Row 1, row 2, row 3, column 1, column 2, and column 3. What will this yield? An answer. It's going to give me a 3 by 3. Okay, so let's make an answer blank. That would look like a 3 by 3. A little tic-tac-toe in there. Board. Okay, so this is row 1, column 1. So all the numbers in row 1 times all the numbers in column 1, well, there's only one in each, so it's 4 times 8 or 32. There's not a second part to this because there's only one in the row. This is row 1 times column 2, so it's 4 times 0 or 0. This is row 1, column 3, so it's 4 times negative 4 or negative 16. Row 2 times column 1, 6 times 8 is 48. Row 2, column 2, 6 times 0 is 0. Row 2, column 3, 6 times negative 4 is negative 24. Row 3, column 1, negative 3 times 8, negative 24. Row 3 times column 2, negative 3 times 0 is 0. And row 3 times column 3, negative 3 times negative 4, positive 12. All right. Well, that looks like we've come to the end. I'm rolling back over to the first one here. So that's going to conclude this lesson. I'll be giving the class an assignment. Thank you for watching.